Thank you very much. Hello, everyone. I am Daniel Chávez. I am a lecturer in digital culture and creative computing at the Department of Digital Humanities at King's College London. I am going to present on a project called Intelligent Systems for Screen Archives, which I've been working on as PI for the past year. This is just a quick outline of the project, just to get us started. So this is a project that is funded by the BFI through the National Lottery, and we have several screen archives as partners of the project, 5 moving image archives in the UK, and Film Archives UK as an organization that could as well. Now, this talk might be a bit different, perhaps, or more specialized in some sense, I suppose, than some of the other ones. We don't, as far as I understand, our partners do not necessarily hold public records. It is a screen archive, so moving image archives, mostly television, film and television. And the other specific thing to mention is that some of this material is also under copyright. So the different types of records here have different constraints than perhaps some of the ones that we've been discussing. But I was told that was fine, and you wanted a broad perspective, so I hope this is helpful. It's also not very text-oriented. This is moving image archives, but we will cover some technical developments. So what's the idea of the project? By the way, this is the team. This is leading the project, as I said, but we have a team at King's as well, working closely with King's Digital Lab, which is a research software engineering unit in the Faculty of Arts and Humanities. So a shout out to them as well. So the idea of the Intelligent Systems for Screen Archives project is to enable screen archives in the UK, regional and local screen archives, to creatively experiment with AI technologies. Part of the reason we wanted to do this is because many times they don't have the infrastructure or the technical expertise in-house to do this, whereas the university has some of that, but we don't usually have access to the data or to any of these collections as well. So we wanted to bring those two steps together. This is what we are in terms of the project. We just had our demonstrator a couple of weeks ago, so it's a good moment for me to come and speak about this, because we have some preliminary findings from the first year of the project, and this is what I'm going to discuss today. So part of the initial year was about archive engagement. One really important thing for us in digital humanities in general was to proceed from not from a tool or a solution that we already had, but to engage archives first to understand what the need was, what the specific use cases could be. So we conducted several interviews with all of our partners, and we derived from that 4 use cases we call MVPs for thinking about sports now, minimal viable prototypes or minimal viable products. So we came up with these 4 ideas. So semantic segmentation, the context builder, which we're going to cover in a minute as place-based search and retrieval, an audience builder, which we're going to cover as part of automated audio description, and semantic integration, which is something that will envelop them all. This is bound to change. It's still work in progress, but I wanted to share some of the things that we have been doing as part of this project. So the pipeline, the MVP pipeline, is not really a menu of prototypes, but it's a chained, they are chained together. They are meant to reflect a larger transformation in screen archives that may or may not apply to broader our archival sector in a sense. But the idea was that each of them will enact a different part of this transformation. So the links of the chain come through atomization, so the breaking down of initial records into much smaller pieces, densification, by which we mean enrichment and various types of metadata enrichment, and then integration, by which we mean especially interfaces at the other end of the pipeline. So in terms of semantic segmentation, MVP number 1, what we mean by this in practice is using LVMs, so large visual and language models, to segment long-form video files into meaningful smaller units. This is one of the key processes in moving image archive pipelines we found, and we designed an initial pilot for this, which includes taking in a video as an input and then separating the streams using the visual stream and the audio stream, aligning them, and then using an LLM layer for reasoning that will then get us some segmentation some semantic segmentation. Now, this is the reason we went about it in this way is because we also wanted to test this in local machine and very consumer hardware, but also in HPC, so high performance computing in the university cluster. So it needed to be scalable. This is some of the initial results and tests. We've been trying with different types of material, newscasts, but also rushes with sound and documentaries and other types of ways of segmenting. So these are making this material much more granular. Most of these records are kept at the level of the record, which usually involves digitized tapes, for example. But tapes or items within the tape, they tend to include a lot of information. There's a lot of things that happen in these videos that are not really covered by the description of these item records. MVP2, which is place-based and retrieval, takes the outputs of MVP1 and then applies a second layer, which in this case, we're using multimodal embeddings. And the idea to do this is to surface some local regional references in archive material. There are two strands to this, again, an audio strand and a video strand. The audio one does transcription, automated transcription, and then we identify different types of plays using Gasteers or Nominatim, which is the other open source resource that we're doing to match transcriptions with plays. And we can then plot this in a map, which we can then use to retrieve or to see. So what you see here is an example of this. I don't have really time to demo this, but you can either click the map or click the transcription, and it will take you to a specific place. And the same goes for the visual strand, so the semantic search for visual shots and visual similarity. So this you see on the left is faceted research. So you take a video, but it will take different subject types, different colors, different visual characteristics that then can be used to match visually similar images across the archive. And the challenge with MVP2 is to fuse them, so vector fusion in this case. But part of what we're interested in from a scientific point of view is what's the best way to proceed in terms of vector fusion for these two strands from MVP2. MVP3 is automated audio description. We're using specialized open source models to generate audio description. We had high hopes for this, and this is the one that in the end gave us more trouble. I have to say here we weren't working with zero in terms of technology here. We started experimenting with a couple of models that already exist with two different labs in the UK. One is the CCATS lab from Surrey University, and the other one is the VGCC with Oxford. They both have models for audio description. We found that audio description, the gap between what's acceptable in terms of audio description at the human level and say at the machine produced level is still quite significant. And we ended up testing video understanding models, which were quite new at the time. They're still very new, but some of the output for video understanding models for audio description. Now, I know you're very familiar with audio description, but the idea is that you need to produce a description that's not necessarily a closed caption of everything that's happening. It's a narrative version of what's happening. It's meant to paint a picture with words to someone who's watching this. And the appeal of this was to open the collections to, for example, visually impaired users. And this is now an active area of research. But this is where we found that the gap is a lot larger. This is a much harder task, and hence it comes also after in the pipeline. And then finally, MVP number 4, which the idea was to do test some algorithmic editing and creative reuse interfaces. Much of this material is going to be used, is queried and used for research, but also for new rebroadcast or creative reuse. Artists reuse them as well, and other types of reuse of the material. And we wanted to test some of the outputs from MVPs 1 to 3 to see if we can think about interfaces. So this is one of the slides that I was most curious to present to you here, also to get your criticism about this. We started from this idea, this Lego metaphor. So forgive me if it's a bit reductive, but the idea was that we had the notion of faceted research as something that already exists, and we thought about this in terms of different pieces that are labeled and that are stored, and the more sophisticated our systems, the better that this classification goes. So this goes back to information science and information architecture. And of course, the idea is that you know what you have, that they're very tractable. At the same time, they depend on different categories that are pre-existing and so on. And we are then confronted with this second image, the one that you see on the right, which is some kind of intent-guided ML idea, where you have all the pieces that are all scattered, and the archive configures itself around intent. So you start, the idea is not to go like a zero-shot sort of search and retrieval, where you know what you're looking for and you get it, but where you start from vague intent. So this was particularly important for some of our archives in terms of discoverability and other things. But the idea was to do a progressive refinement. So this is a process by which users could progressively refine, and the archive itself would reconfigure around their need or their use. We tested, we started playing with some ideas for interfaces about this. What would that mean? And the interfaces, what would these interfaces look like if we had to redesign the idea of a search box or the idea of a catalog interface on top of some of the data that we could produce through enrichment. And of course, this would be user dependent as well. So finally, to round the talk, in order to do some of these things, we were building kind of middleware tools, middleware layer, we called it, that kind of reshapes moving image collections into data that is useful for developing things downstream. And this is a tool we've been developed and testing. It's called FrameSense, and it takes as inputs large collections of video files and organizes them in the background in different ways that can be then used for downstream processing, especially with LVMs, but also with LLMs and other type of modular systems. But the key for this is that this should work on HPC, because the volume of data that the screen archives have tends to be quite large in that sense. So we had the demonstrator, as I mentioned, last couple of weeks ago. We had some of the outputs that you can see on the screen. But the main thing that I wanted to leave with you today was also to have these early lessons from the project. And one important thing for us has been the idea of developing some of these technologies with the archives, or trying to develop them as close as possible with the archives. So one of the reasons we're quite interested in this is because we've been testing open source models. All the developing has happened with our own compute resources. This is partly because of the strict data residency of some of the screen archives, but also partly because we believe that there is a benefit in developing these things together. The reason is because the knowledge that we create, we keep institutionally. Whereas if we outsource some of these learnings and we buy tokens, and this is the point about using providers versus sovereign AI that was mentioned earlier today, is that some part of what we are not counting in doing this is the knowledge that we can create about how some of these technologies work or do not work. So we think that it is valuable to understand the underlying technologies and not just take these models as they are or as they are sold to the archives. So with that in mind, that's it in terms of the intelligent systems for screen archives. Thank you.